So it's time for our second talk. Our presenter today is Joe Kaufeld, who I think is going to give us an exceptional talk about exceptions. Please make him welcome.
Thanks, Chris. All right, so my name is Joe Kaufeld. I'm a senior software engineer for SpotOn Inc. And today I want to talk to you about exceptions. Specifically, I want to talk to you about a theory. I have a theory that basically none of us use exceptions the way that they're meant to be used, the way that they're actually designed to be used. So I don't think we're going to get too into the weeds here. There will be weeds, trust me. But hopefully my goal is that everybody comes away with this learning one new thing that you didn't know exceptions could do, and maybe look at some of your projects in a slightly different light. We'll see how successful I am. So, in general, what we're going to do is we are going to talk about exceptions. We're going to look at what is an exception, just kind of lay down the base groundwork. We're going to talk about writing your own exceptions and why in the world you would want to do that. We're going to talk about using exceptions as a core piece of your design architecture. This is where all the fun parts are. And then finally, we're going to look at fun with exceptions, maybe some extra things that are built into the language that you may or may not know about. So let's get into it. In order to really discuss exceptions, we have to come to a common understanding. And in order to come to a common understanding, I decided to look up the question, what is a Python exception, in the built-in documentation. And it turns out that answering the question, what is an exception, is surprisingly hard. There's basically nothing in the actual Python documentation that answers this question. So I did a little looking, and maybe there's something that I missed. I won't discount that entirely. But I found one concrete answer. Just one. It's buried in the tutorial section, not even in the bit about exceptions specifically, but it is buried in the tutorial, and it says concretely that an exception is an error, which technically correct is the best form of correct. So yes, an exception is an error. But that definition is not super useful. So hopefully we're gonna tweak it a little bit. So in Python, we have two different subsets of exceptions, and one of them we're going to completely ignore for the entirety of this talk. So we have exceptions that are related specifically to the language itself. So you have like syntax error, indentation error, that sort of thing. They're related to actual parsing. Those work. They work great. We don't need to do anything to those. So we're just going to put those all in a box, and we're going to forget they exist. The ones that we're actually going to talk about today are the ones that are related to things going wrong with your code. It's valid Python code, in theory. It's just that it has problems when it runs. So attribute error, OS error, things like that, type error. So when we look at this bucket of exceptions, all of these deal with one very specific thing, if you look at it. They all deal with logical issues that are specific to the logic that they are currently executing on that line. And they're very limited in scope. They must be. The core developers can't imagine ahead of time all of the horrible things that we're going to try and make Python do. So they have to give us a somewhat limited bucket to pull from. So what I want to do is I want to try and redefine this. And the reason that I want to try and redefine this is because we're going to take all of the ones that are built into Python, and we're going to apply an extra label to them. Show of hands, this is an audience participation question. How many of you have been working with a third-party application, third-party anything in Python, and gotten a generic Python error that forced you to look at the source code for the third-party package you're trying to work with? I have, and the vast majority of us in this room have too, and it's infuriating. You just want to use it. You got it because it's supposed to do the thing that you need done, right? It works. In theory, it works. Hopefully, it works. Clearly, it doesn't, because now you have to go and debug it. So we're going to apply an extra definition here. I'm going to redefine what a built-in based exception is as an exception that is an error notifying that a logical failure has occurred in your application, which, by the way, the slides hopefully will be available for download if the QR code I put at the end actually works. Fingers crossed. So it's a logical failure. It is extremely limited in scope, hyper limited in scope, because it cannot possibly know more. It cannot possibly give you anything more than this. So how do we actually provide more information about our actual project so that someone can fix it? If they're having an issue, they need to know things that only you, as the developer or as the primary maintainer of a project, can know. So we're going to introduce a new definition. We're going to keep this one, so a built-in exception, missing a word, is an error that notifies a logical failure has occurred. However, Python gives us the ability to make up for this deficiency in contextualness. I'm sorry. So a custom exception, I would argue then, is a contextual error about what the user is attempting to do within the project as a whole. There is no way to provide this information using the built-in exceptions, the built-in systems that Python provides. So it's up to us as the developers to provide this information instead. I have an example, and it looks like this. Which one of these two errors is more useful to you? On the top, we have a type error about concatenating a string and an integer. And on the bottom, we have a configuration parse error, where the value appending data is borked. One of these is much more useful because in the type error case, well, actually, in both of the cases, this error is going to be raised in a function that's related to parsing a configuration file, but it's going to be in the middle of a loop. So first, you're going to have to figure out where in the world the third-party thing is. Then you're going to have to figure out which iteration of the loop we're actually on. Then you're going to have to figure out what piece of data it's actually looking at in the loop. But you, as the developer, have the ability to just provide this information, provided we think about it first. That is, as always, the caveat. We can't write and plan for the things that we don't know about, so you have to think about this as you're developing, as you're writing things. But this is totally doable. And also, I've done something very specific with this slide. When I tested this, I stripped out all of the lines except the last one from the stack trace. Because what do we teach newbies in Python? I taught Python for about 3 years at the intermediate level, and one of the core problems that I ran into as an educator was that we teach people to scroll all the way down to the bottom of a stack trace and work your way up to see where something went wrong, right? Error begat error begat error. It's the book of numbers all over again. So with this, if you take away every line but the last one, which is more helpful? One of these provides a contextual notice that says, you messed up something, it's in a file that's completely unrelated to this function, but this is where you need to go, and this is what you need to look at in order to fix it. And one of these says, I had a problem parsing a file. One of these is useful to someone who's trying to use your code, and one of them is not. One of them's useful to you as the developer, but not to the person who's trying to use your code. I argue you can have both of these. You can have the best of both worlds, but it requires a little bit of extra setup. So, how do we do this? This is the part that probably everyone in this room already knows, but I'm going to cover it anyway. So, building a custom exception is super easy. You have a class, you name it whatever the hell you want. You can have even fun names. The common, proper way of going about it is to have it end in the word error. If you want to be very fancy, you can have it end in the word exception, or you can say it exploded. All of these are totally valid. You do have to inherit from exception, which always feels a little bit weird anytime you're working with things in the global scope. It's like, it feels like it shouldn't work this way, but it's just a class. It does. It's magic. I don't know. I do know. Anyway, there is a class that exception itself inherits from. It's called base exception, and generally speaking, just forget that one exists. Inherit from exception because that's got all the fun stuff on it, and that also has some additional hooks that I'm not going to get into. And then you just have to pass. If you want to have additional logic on here, you totally can. It's not going to stop you, but this will behave exactly like an actual regular exception. Once you define it this way, this is a first-class citizen in Python. You import it as a regular class, and then you raise it as a regular exception. You can catch it as a regular exception. You can pass everything that you would normally pass. A message, additional information, context, everything just works out of the box. It's an exception. It's exceptional. Okay, that's the only time I'm going to do that. So, now that we have this, now we can actually do something with it. I have an example. It's contrived, as every example in a talk actually is, but I do have an example. This is a very slimmed down version of code that I actually have. So, you can use this type of architecture to absolutely bulletproof functionality in a way that helps both you, whoever's consuming your code, and hopefully your coworkers. So check this out. We have a fairly generic function here. We're going to get data from a predefined URL. We're going to check to make sure that the request succeeded, and then we're going to return a JSON response. This is not exciting in the grand scheme of things. We all have tons of little helper functions that work just like this. But out of this function, I stopped counting at 8 different ways that it can explode. So what we're going to do is we're just going to pad it a little bit to try and bring that number down and hopefully make it a little bit easier to work with. So out of this, the first line, we have explosions if the website's down. We have explosions if our internet connection is questionable. We have explosions if AWS is down. Again, we have all kinds of things that can go wrong from a connection standpoint. Then on the second line, we have an issue if dummyjson.com decides to return a 500. If somehow we queried it wrong, less of a problem since we're hard coding the URL, but still a 500 is super, super possible here. And then actually our third line is one of the most questionable out of all of it, because not only are we returning the response, we're actually casting it to a dictionary format before we return it. So what if there's no data? What if there is data? Hopefully that's our success condition. That's our green route that, yes, huzzah, we got the things that we actually asked for in the first place. How many of you, this is another audience participation question, how many of you have gotten an HTML error page with a 200 response code where the HTML says, I'm sorry there was a 500 error? Yeah. You laugh because it's true. It happens, and it's horrifying, but it absolutely happens. And you know what response.json will do when it gets an HTML response? It'll raise a JSON parse error at line 1, character 0. The hell does that mean? That's not helpful to you. That's not helpful to anybody using your library, but it's not your fault. It's the website's fault. Whoever you called, there was bad data introduced to the pipeline that you are now responsible for, even though it's not your fault. We can fix that. Now, we are going to make one other change to this, which is the empty data question. Because technically, if everything goes right, there are 2 possible ways that this can end. Either we get an empty JSON dictionary, or regular dictionary, but it's still empty. There's nothing in it. Or we actually get the data that we asked for. And in the context of this particular application, getting an empty response is just as bad as getting no response at all. We expect there to be data. So If the question is, what do we do if we get an empty response versus a regular response, then we have a predefined pattern for dealing with this in Python. It's called a guard clause. I mean, it's guard clause in every language, but still. It's called a guard clause where we define our information and say, this is our new variable with the data that hopefully we have. Now did we actually get the data? And if we got the data, then we can do stuff. But this is qualm. I've lost actually count of number of qualms, but I have qualms with this. So with this, you are forcing the person consuming your code to first realize that getting no data is a possibility, and second, you are forcing them to deal with it. This is just as bad as something that we do even more than this, which is do something or return none. I know everyone here has written those. I've written lots of those, and they're still bad. But doing something or return none forces you on the other side of that function to deal with the none that can be returned. There is a clearer, more explicit way to do that. So now, let's take a look at beefing up this function a little bit. So the first thing that we're going to do is we're going to take the base exception class, what all of the HTTPX errors that are related to getting information from somewhere and putting it somewhere else, all of those are brought from AttributeError. So we're just going to catch that one, and we are going to have a custom exception called dummy JSON connection error, which specifically states, just by its name, we have an issue connecting to the dummy JSON website. There's no other place that we're going to raise a dummy JSON connection error unless it's an issue connecting to this website. So already we have a better idea of what happened. Then I'm going to add in another one. This is mostly personal taste and arguably may not be correct for everyone's setup, but I want to posit it anyway. I made another one called empty response error. And in our empty response error, we have an exception that is actually raised if nothing is returned. We have a dictionary that has no data in it because I want whoever uses this function to explicitly define what no data means to them. If they want to implement a guard clause, so be it. At least then they made the explicit decision. What does it say in the Zen of Python? Explicit is better than implicit. Returning none or returning a data is implicit behavior, and it bites a lot of people. I guarantee it's bitten you. So let's fix that last bit, the response.json bit. So if we take this, then we can wrap that entire section in a JSON decode error block that we're now going to return a garbage response error. How many times do we expect to see a garbage response error? Hopefully not many, but it could happen, and we want to be prepared. So now we have 3 custom exceptions. Admittedly, we only had 3 lines of function to begin with, but now we have 3 custom exceptions that provide a contextual understanding, better contextual understanding, of what actually went wrong should anything go wrong here. Obviously, the goal is that nothing does go wrong. But we're all engineers. Everything goes wrong. It's a feature. So out of this, there's one more thing that we still have to do, but we'll get there. Eagle-eyed viewers will realize that I've left something out here. So in our custom exceptions, on the left, we have all of the exceptions that I personally ran into while I was trying to make this explode. There are more, I'm sure, that could be raised from just these 3 lines, but these are the 8. These 8 specifically are related to things going wrong at a logical level. Anytime one of these 8 was raised, it didn't actually tell me what had happened contextually, because it can't. It doesn't have that level of contextual awareness to provide that level of information for someone who's trying to use the function. It just can't. There are limitations, and we've reached them. So we have now 3 actual usable custom exceptions: dummy JSON connection error, empty response error, and garbage response error that we can then utilize however we want. Now back to the example. There was a specific thing that I omitted, mostly because it's additional syntax. So now we can actually get into it now that we've addressed everything else. When you catch an error and then raise something else, you are throwing away data. That's not super great, especially when you're trying to debug the contextual issue that happened. So now you may have more information about what exploded. Maybe you have information about other things related to the explosion, but you need to know specifics about why it exploded, especially if you're going to report an issue. So there's one minor change that we need to make to that example, and it looks like this. So when we have the as keyword here, we're going to take the entire stack trace from, for example, HTTP error, we're going to assign it to the variable e, and then we're going to add that as a from in the next line. Now this works the same way that the with operator works in Python, so anything that's contextually under that with will be removed at the end, right? So in an except, that as means that the E will be destroyed as soon as we leave the except block, so we can safely reuse it, no problems whatsoever. But what this will do is it will say at the very bottom of the stack trace, remember what we talked about earlier, people scroll all the way down to the bottom to see what actually went wrong? We get the contextual one at the very bottom as the last line, first thing people see. Then above that, now we have details. Why did we raise the contextual error? What went wrong that brought us to an understanding that we couldn't connect to dummyjson.com? Now we're really getting somewhere. Same thing goes for below. We have a JSON decoder error that we're storing, and then we're saying we got a garbage response. The garbage response was raised because we had a JSON decode error. The JSON decode error has all of the information, in theory. Decoding HTML as JSON never goes well, to try and debug this. But at least we have more information than we had in the beginning, which is always nice. So how do we actually utilize this? Now that we've managed to take our 3-line function and bloat it into something much larger, but hopefully much more stable and production ready, what we can do is, on the other side, here's how we might, maybe, potentially, actually use this. We can use a try except block to say, here is the data that I expect. Either I get it or I don't. End of story. If it succeeds, I got my data. And frankly, that's more of a guarantee than most of us ever get. So we have an accept block. We can accept our 3 custom exceptions. And we can say, look for these. If we get any of these, do something else. Or we can break them apart. Maybe we only want to save or watch out for the dummy JSON connection error and the garbage response error, because we want to handle those separately from anything else. If we have something like this, then now we can handle this in a way that allows us to split our logic that the original function did not provide us, especially if we were just trying to catch those original 8 generic logical exceptions. The logical exceptions inform us that something very specific has gone wrong. The contextual ones give us the understanding of what went wrong just by reading our code. This is why this is so important. Yes, this is a little bit longer. Yes, this is way easier to debug. I'm just saying, way easier to debug. And you have the bonus of being able to pass this to your coworker who has never seen your code before, and you should be able to get a pretty good understanding of how this code block works just by taking a look at the names. It's just like naming functions. You want to name them so that someone has a contextual understanding of what your function is supposed to do, right? We want a contextual understanding of how this can go wrong. We have to apply the same level of care to both sides. You can split this out as much as you want. In this case, we're raising another custom exception. Maybe you have a general exception that's the name of your program. You can raise that here. You can do something else. But the important part is you are handing control to the person who is using your function of how they wish to use it. No more of this, yeah, we'll just catch everything and return none if it doesn't work. That causes more headaches than it solves. Is it clean? Is it neat? Is it neat? Yes. Is it clean? Yeah. But in general, you want the person consuming your code to have more control, and you want them to be able to understand what can go wrong and how to interact with that. I'm running a little low on time, but we're almost done, so bear with me, because now we get to the cool stuff. And this is more stuff that I don't actually have proper demos for, but we're just going to talk about it, because hopefully in here there's something that you don't know. We'll see. So, cool stuff that you might not know. Have you ever written? The answer is yes, but have you ever written a try except block that immediately assumes at the end that you actually made it through, or immediately has a check on the other side to see if you made it through the try except block? It's built in. You don't have to have that check. The else section, although I do have qualms about using that word since it's used elsewhere in the if else. Anyway, using else here means that will only ever run if you successfully made it through the try block. It's done. The guard is already there. You just have to use it. In order to use it, you have to know that it exists. So here you go. There's another one too. There are actually 4 pieces to this, because the last one is finally. If you stick a finally at the end of a try except block, then this is where you can put all of your cleanup stuff. If you have additional code that needs to run, if you have additional checks that need to run, if you cannot live without putting a guard clause somewhere, put it here. Because that's the spot that this is actually designed for. And you can stitch all 4 of these parts together. You can have a try, except, try do something, except it exploded, else it didn't explode, so do this, and finally, clean up. You can have all 4 of those, and it'll work just fine. And it's actually really startlingly complete. When I was learning Python, I struggled a bit when I originally learned try except, because I learned it as you try something, you catch the error. That is it. That is all it can do. That's all it's supposed to do. That's not true. You can use this to have really complicated logical flows, but you have to know that it's here. Now, this one's super cool. Did you know that you have built-in abilities to have groups of exceptions? Because I'm not going to lie to you, I didn't before I started researching for this talk. And exception groups are built in. So what you can do is you can create a list of predefined exceptions, make your own messages, whatever you want, stick them into an exception group, and then raise the exception group. And this will very prettily format all of them in a row, in the order that they were called. Imagine, going back to our configuration parser example at the very beginning, imagine parsing a config file, building an error for every line that fails to parse, and then just saying, we failed, but here are the 18 things that you need to fix. It's built in. I didn't know that. I do now. But it's just built in, and it looks great, and it works really, really well. So you should definitely take a look at this if you didn't know this was a thing, because it's really cool. And there is additional handling for this, because the next question that I had was, okay, what if I have a group where I'm still going to catch things? Okay, that's also built in. The syntax is not as great. It's an except with an asterisk right after it, but this allows you to pull out specific exceptions just the same way that you would for something else and deal with them, but then whatever exceptions are left in the group will still explode the way that you would expect them to. It just works. And even when I was playing with this for just a couple of evenings, I was able to do some really, really cool stuff with it. I think you can too. Last one which is every bug tracker application, every third-party bug tracker, Bugsnag, Sentry, Datadog, etc., has a breadcrumbs functionality. So you can basically tack arbitrary data onto an error before you send it on, right? What I didn't realize was that that's built in. If you predefine an exception, if you create an exception, assign it to a variable, you have an add note function on the end where you can just tack on as much data as you want. You want to have additional information about what went wrong. You want to have additional information about where it went wrong. You want to have additional information about something that's not even in the current function, but it's related to runtime or whatever. Just add it to a note. Add as many notes as you want. When you raise that function, or when you raise that exception, you'll just have all of that information. If you send that somewhere else, you'll have all of that information, and it's all built in. Awesome. All right. That's really all I've got. So thank you so much for your time. I really appreciate it. And if you want these slides, fingers crossed this works. But thank you very much, guys. I appreciate it.
Surprise, I was behind you.